This is Koiro with another off-topic video, or it's not off-topic, it's kind of an introduction to the next part in my Resurrection series that will be the part 9. And in that video I will talk about the power bricks from the Commodore and the different makes, like this one that was with the newer C64s with the short cord. And these PSUs are known to fail, and even though they are reported to fail at an alarming rate, I myself have not seen many of these that has failed in the way that is described as the most common failure. And the most common failure that is reported on this power supply is that they fail short. And that is due to overheating and operating the components inside the power supply at max capacity all the time, and in some cases above capacity. But when you do get a brick like this and you connect your multimeter to this before you actually connect it to a C64, is that a good test? And my answer to that is no. To be able to test this PSU, you have to load it with the normal load that you will, at least the load that you will run it in your day-to-day use. And these old power bricks, they have stated that they are 9 volt 1 amp and that they are 5 volt 1.5 amps. And this slightly newer one is rated 1.7 amps at the 5 volt, and that is because the 5 volt rail on this power brick supplies all the 5 volt in a shortboard C64, while it's not supplying the VIC2 chip and the circuit within the CAN on the newer ones. And there are also a lot of cartridges and other stuff that you connect to a C64 that gets its power from the internal 5 volt supply. So in today's video I'm going to make a homemade C64 power supply tester that will actually load the PSU so that you can see if it works under load. And today's video I will be filming down in my shed. So let's get on with that. The power supply tester, I need to build it as a rather simple circuit, I think. And what we do know is that out of the C64 you have the 5 volt rail that's DC and regulated, and you have the 9 volt AC rail, and that means we have to plug into this and get the 5 volt DC into our circuit like so. To measure AC voltage with a multimeter like these ones, these are cheap China parts from AliExpress or eBay or whatever. You have to first rectify this because these can only measure DC voltage. And that means that we do have to have a rectifier on the inside here, and we will build a full bridge rectifier to rectify this. And I also need a huge load on this. So on the 5 volt rail, this will look something like this. You have the GND down here, straight to the output. But on the input I will supply a voltmeter, and here I will have a switch, and this switch will be in form of a relay that either switches like so and take this straight out to the output 5 volt, and then it's just going to measure the open voltage power or the power that is supplied to the C64 that is on this side. So this is C64 out, we can call this, and this will be a normal C64 power plug. But we do need to have a load on this, and here we will have a huge resistor that is the load DC, we can call it, that will drain all the power we need to drain to test this to ground. And on the AC side it will be almost the same. Draw this like so, and I can have the switch on the relay just under this one, like so, and we will have the R load AC here, and this we will connect like so on this line. That will go straight to the output like so, and this line will go straight to the output as well. So here you have 9 volt AC out. This one will need to go to this AC line, because then we connect this resistor. When this relay goes in this position, then we will switch in the loads and we will disconnect the output to the C64, so that won't be damaged due to failure on the input voltage. And to control this relay, we need to have a relay control circuit here, and this is a 5 volt relay. I will get this switched in by using an ordinary switch like so, and connect this to the 5 volt DC line, and this one will be connected straight to ground, so I can just connect it like so. So when I put in this switch, I will activate this relay and I will switch in this load. Yeah, we can also put an LED here so that we will see when this is activated, like so, and this is LED, like so. And to measure the AC voltage, we need a full bridge rectifier, as I said. We will just draw one in here, and I need a capacitor to straighten this out, like so. And this full bridge rectifier will have the plus up here, and this will be like so. So that's our rectifier. And to connect the voltmeter here, I will use a variable resistor like so, and have this line connected here to the voltmeter so that I can calibrate this. Yeah, I think this will be about the circuit we need to test this. And these resistors needs to be rather powerful. If we look on the output of the C64 power supply, you have the more common one for the bread bins is 5 volt, 1.5 amps, and you have 9 volt AC, and that is 1 amp. And if I need to measure the power that is coming out of this, you can just multiply these ones, and you have this resistor needs to be 1.5 times 5 volt, and that's 7.5 watt, and this one is actually 9 watt. So that is what these resistors need to be able to handle as a load. And I'm going to make these by connecting these resistors in series and parallel, and these are half watt resistors. So each one of these can drain away a half watt without burning. But that's the maximum load, so we will need to do some, have some safety margin on this. And I'm going to use a breadboard. I'm going to use this to plug for connecting to a C64. I'm going to use 2 of these multimeters. I'm going to use a relay. I'm going to use a switch. I'm going to use the plug to connect to the power supply. I need a capacitor. I need an LED, maybe this one, maybe some other. And I need a lot of these resistors. And I did make a basic power supply tester when I made this adapter for the plus 4 back in the day, but this is only measuring this without the load or with the load of the plus 4. So that's not going to help us. This time the video will not be about soldering, but I will tell you what we see when we see this kind of board. And this board is like the normal prototyping board. You have the connections like so. and so, and they are connected, and these lines down here are connected. And you can break these lines by using a drill bit like so and take away this on both sides. So this perf board is the kind I will use. And as I said, this time it will not be about soldering, but we are going to do some more calculations about the resistors, because I need to know what values I need for this. And to drain about this much power from this one, we have to solve for the resistor on Ohm's law, and that will require like something like this. And we have 5 volts and we have 1.5 amps, and that will be approximately 3.5 ohms. We are rounding this upwards, and for this one we will have 9/1, and that is quite the simple equation, because that will be about 9 ohms. So I'm going to combine a lot of resistors, so I have enough of them to drain the wattage. And on this I need about 20 of these resistors, and in this one about the same. And these take some space, so I will have to put some space on this board for them. And also I'm going to lift them a bit from the board so that the heat will be able to dissipate. If I connect everything of them together and maybe with no space and no air, this will actually be a huge lump of resistors, and the ones that in the bottom and in the middle, they will actually get quite warm. So I do think that these are specified to be about half watt if they are in free air. So when you encapsulate them, they will take much less. So I'm not going to show all the soldering and stuff in this video. So I'm going to sheet and just have the finished product like so. Yes, and here are already made tester, and as you can see, I have used a lot of resistors, and these are the resistor for the AC side. And I've lifted them here from the board, so they are a bit higher, and I do have some air around them. And here I have used, I have 10 resistors in this, and I do have 10 resistors in this. So I used 20 resistors for this, and that should be able to handle the 9 watts. And on this one I have used 6, 12, 13, 14, 15, 16, 17. It should also be able to handle the 7.5 watts of load. And here is the full bridge rectifier. Here is the capacitor, the LED circuit with the series resistor, the adjusting circuit for the AC voltmeter, and this is the AC voltmeter, DC voltmeter, and you have the on-off switch. And I've just connected this as efficient as I could on this board. I might have been able to do it more efficient, and I might choose another layout if I do this again, especially with these resistors, to get them maybe not so close to anything else. They get quite warm. And I also soldered in this connector that should go to our C64. And I'm just fastened this with some wire here on some available lines on the perf board, so that it won't get tucked away. And I have not made any spacers and such, but I probably should. And I've not made any enclosures and so on, but I'm going to test this now and see if we actually get any readings. I do have my power supply here, that is the one that I use to test stuff out here in the shed, and I can connect that one first. It has an on-off switch on the brick itself. Yeah, maybe I just keep this like so. Turn on the bridge, and okay. I don't know how visible this is on the camera. We have a peak, okay. This is 5.16 volt and this is 10.67. It switches a bit. And if I turn on the load, you will see that this LED lights up. And this switches to 506 volts and this down to 10, yeah, without any decimals. And now the resistors will start to get quite hot, so will the internals in the power supply. But we can see that this power supply actually behaves quite good. It does not fail in any way, but I do smell now the smell of heating resistors. And you can see that this is actually starting to act up a bit. It's compensating for something, and that's since the internal heat on the circuit. And then I speak about the internal heat on the circuit inside the power brick. I turn off the load now, but this was able to handle the load. And if I connect this side to a C64, it will power the C64. Zoom like so. I have my C64 here, and this is one I've used for testing before. It's totally okay, but it's missing this key. And this is C64C, but not with the short board. It is the one with the longer board with 2 memory chips. And you can see this turns on just nicely, no problems at all. And you can see when I turn on the tester, it disconnects the C64, so I won't damage anything. And now you can see the AC voltage is actually dropping below 10 volts. And now I have turned on the C64, so the C64 is loading the circuit. And I do plan to put on some test point here, so that you will be able to put on an oscilloscope and maybe also some other kind of load if need be. But this is my C64 tester with this power supply. And I'm going to connect now one power supply that I got from Tommy in Arctic Retro. He did say that it failed, so I will not connect it to the C64. I will tuck that away, and I will turn off this one and disconnect this. I have not tested this power supply myself, and I normally don't trust this power supply anyway, but Tommy said he had tested this. But to test and measure on this plug, it's rather difficult, because it's very difficult to handle the holding of the pins without shorting out anything, and you also can get the bad measurements because you are not holding the pins hard enough to the steel. So I'm going to connect this to power, and I am going to connect this to the tester. And I get nothing. So nothing at all. So it appears totally dead. I will check the... yeah, there could be some fault on this cable. I don't think so. Okay. I will disconnect this again from the mains, and I will check this fuse. That just measure well. Yeah, then I will just try to test if there is anything at all out from this one. And I connect it again to input, and I take this to 20 volt DC, try to measure on the DC rail, and nothing. And I measure on the AC voltage, and nothing. Okay, this is kind of special because there is just one fuse inside here, but there could be something wrong with the power brick itself, of course, or there could be something with this lead that lines into this. You have this one here that looks a bit suspicious, but this video will not be about testing this power supply, so that will be for the next one. Yes, but to make sure that we actually have not broken anything, I'm going to connect this one once again and turn it on. Yeah, and it fires up straight away. So we do know that this circuit is working, and we do know that this is not working. So then we have something to look at in my next C64 Resurrection video, part 9. That will actually be about C64 power supplies and how they work and what they do and how they fail and how they do not fail. So until then, this was just going to be a short video anyway. Thanks for watching. Hit like and subscribe if you want to be notified when we post new videos, and hope to see you in my next video. Thanks for watching.